It's it's so nice to see so many faces at our lunchtime lecture series. Welcome, and welcome to the Department of the Interior. If you're public members coming from outside the building, thank you for navigating your way through our hallways to get here. My name is Diana Ziegler. I'm the acting director of the Department of the Interior's museum, and this is part of our monthly lunchtime lecture series where we highlight the workings of our various bureaus at the department. So this week, of course, we are highlighting the National Park Service and some of the work that's being done just down the street at the National Mall. I'm very pleased to be presenting Ned Wallace. Ned is recently with the National Park Service. Ned received his Bachelor of Science in Civil Engineering from Colorado State University. He has 26 years of experience in the private sector as a consultant. He spent 4 years with the Nevada Division of State Parks, where he was one of 2 engineers in the planning and development section, which was responsible for planning, designing, and construction of projects spread throughout 26 parks in the Nevada State Park System. Ned joined the National Park Service in 2010 at the National Mall and Memorial Parks as on-site representative for the construction of the Martin Luther King Jr. Memorial, and has worked on projects at the FDR Memorial, the World War II Memorial, Benito Juarez Memorial, and African American Civil War Memorial. So you've been busy, Ned, since you got here. So currently, Ned is the representative for the Washington Monument Earthquake Repair Project. Please welcome Ned Wallace.
Thank you. I'll be talking from a set of slides here that were put together, as you can see, back in July of 2012, but adding some additional information based on work that we've been doing so far. The first part of this is kind of a recap of the main things. And of course, now it won't go. All right, the earthquake in August of 2011 was a very large earthquake for this area. It's been studied heavily since and is still undergoing study. There are groups at Lehigh University and VTech that are currently still working on determining exactly what made this earthquake different than other earthquakes and why it was so unexpected in the area. Brief history on the monument. Probably most of you know this better than me, even if you're from around here. 555 feet 5 and 1/8 inches tall, and built in 2 phases. On the day of the earthquake, I was at the Martin Luther King Jr. Memorial because we had just done the soft opening and we were seeing how things were working in anticipation of the actual dedication, which was to come on that Saturday. After the earthquake hit, I was asked to go over to the Washington Monument to get a first-hand look at what was going on. The picture here from outside the memorial is taken from a Park Service helicopter. I was flown up in the helicopter to look at the outside of it and went up the inside. Actually, I had gotten up to about 300 feet up when they called me and said, no, come down and get on the helicopter, and then I went all the way up the next time. So these are some of the things that we found. The most striking thing about the damage the day of the earthquake was that on the plaza there was very, very little debris. What had fallen out and come loose was mostly mortar from between the joints. It wasn't until you got up to nearly 450 feet up on the inside and saw things like the picture here with the sunlight shining on the wall that you knew something was really wrong. There are no windows in the Washington Monument until the 500-foot level, so seeing sunlight on the walls was kind of a surprise, especially given that there was virtually no evidence of interior damage until you got to at least 450 feet up. So obviously, after we looked at this, we knew that this was well beyond the scope of what the standard Park Service engineer can deal with, or any of our masons or staff. So we went about selecting what we felt were the best people to do this kind of work, and with Janie, mobilized their people. It took practically everybody in the country they had that trained to do this so that we could do it all at once. And the sense of urgency for that was that after the earthquake, the next thing that happened was a hurricane was predicted to hit here. Now, obviously, if you can see sunlight through the walls and a hurricane is coming, we needed to get it looked at and get those holes plugged to the greatest extent possible, because water damage to a building is frequently much worse than any of the original structural damage. So the first priority was to get somebody signed up, get somebody to look at it, and make as much of an emergency crack sealing to prevent water intrusion. So they came out, they responded, they put on a good show for everybody, and they had a great time doing it, I understand, and continued to specifically document what they had found, and then retired back to their offices and started working on plans for us. So cracking of the marble panels was significant. Water was intruding into the monument. Mortar was displaced on the outside, so a lot of the repointing that we did in just like 10 years ago came out. That actually is by design. If the mortar is the soft piece and we get an event like this, the mortar is sacrificial. It's supposed to break and fall out so that the stones don't. So that part of it, although it's a little disappointing that we get to repoint the whole thing again after only 10 years, the mortar did what it was supposed to. Here's some of the West Janey folk with some of the pieces that had broken but not fallen. So one of the really critical elements that West Janey did for us was finding broken pieces that were loose but not loose enough to have fallen, thus making it safe to continue the cleanup operations, continue with the analysis and design of the repairs. Here's fun pictures. You know, it's like there's only a few engineers that get to do this, and I'm really jealous because I'm not one of them. Some of the things you can see from here, kind of ancillary damage, is not only was the stonework damaged, but the lightning protection system was damaged. So with the project that's ongoing now, we are going to be replacing the lightning suppression system because the monument does get hit by lightning frequently. There are lots of pictures in our Park Service library of the monument getting hit by lightning. One of the interesting things that I got in an email this morning was that when they removed the brass aerial ring, kind of like one of these points that you can see here, well, at the very top, there's a little square piece of brass that fits around the aluminum top of it. Well, the brass was just stuck on the aluminum, and then it gets hit by lightning, so we've had a little bit of what's called dielectric corrosion. You get dissimilar metals together and start applying current to them, one of them corrodes. So you would think we would not have a problem with an aluminum tip on the Washington Monument, but we do. So unfortunately, I'm going to have to go look at it, you know. And you can only do that from the outside. I know it's a tough job, but somebody's got to do it. There were a number of more troubling cracks, more troubling conditions. The pyramidion, the very top from where the angle changes up, is really a fairly intricate piece of stonework with haunches and other ribs interlocking to kind of hold it together. And this is kind of a cross section here from West Janey's work that shows how there's a bit of a tooth there by the lower arrow that locks into a haunch. Well, when the teeth or the haunch are broken, that was probably the most significant structural defect after the earthquake. Those are the kind of things that if one of those were somehow to let go, there's still other mechanisms to hold it in place, but that would be a very serious problem. So a lot of the most significant repairs are interior to the pyramidion, up at the top where these teeth and haunches were cracked. This is kind of an explanation from West Janey again, showing the gravitational forces there, and the left, under normal conditions, it's all weight bearing and every piece basically is kept in place by gravity from the pieces above it. But when things start moving sideways, as they do in an earthquake, stresses are put on the rock in unanticipated ways. In 1883, when this was completed, there were no earthquake codes for Washington, D.C. This was not anything that this was anticipated to ever experience. Here are some additional ones from West Janie showing how they actually documented where the damage is, and you can see they found not only current damage from the earthquake, but documenting some of the older cracks and other things so that we have a complete condition assessment of it at the end of the day. So in this one, you can see there's a lot of damage noted. A lot of this damage below the 450 point was really fairly superficial, not a whole lot of major cracks or pieces falling off, but again, the sacrificial mortar that had given out. Again, it's just, to me, it was just incredible that I could walk to 450 feet, and if I had been blindfolded, let loose in the middle and told this building just had an earthquake, you would not have been able to tell if you turned around at 400 and walked back down. You would have said it's fine. So the exterior repairs, so you can see there's a number of different repairs. As we are speaking, they are doing small-scale mock-ups of each of these repairs and doing individual repairs at points on the memorial in order to ensure that the repairs, as West Janie envisioned them, are functional and can be implemented wide-scale on the monument itself. It's very unique work, so instead of just having a perfect plan that a contractor just goes out and does, this one is a much more interactive project. The contractor goes out, documents again, because now they're not hanging on ropes, they're standing on platforms, and they can look at it and say, well, you know, you guys were doing the best you could, but you were hanging from a rope and we only gave you 3 days to look at it. We can now stand here with 4 people looking at it all saying, do you see the same thing we saw before? And decide. So there's a little bit of changing going on the fly as we look at it, but it's necessary. It's a unique project. It's a unique structure. There isn't a canned fix for something like this. So in theory, West Janie's got all the work figured out. And, you know, Yogi Berra said in theory there's no difference between theory and practice, but in practice there is. Well, in practice we're having to practice some of the repairs, make sure we've got the right techniques down, make sure that everybody is on board with these being the best fix, and then it'll be more or less full speed ahead after that. So we're at the point where we have had a ton of work expended in just getting to the point where we can do the work. So when you've got to fix something that's 450 to 550 feet off the ground, obviously there's a huge amount of temporary structure involved. And in fact, when we took the panels, the pavers off around the base of the monument in order to build the foundations for the scaffolding, one of the first things we found was right where they were going to put a piece of the scaffolding support on the edge of the foundation for the monument, there was an eye bolt. Nobody knew it was there. It had been there since they built it in the first time. Uh-oh, this is historic. We have to redesign and work around it. So it's really kind of interesting that on a well-documented and quite lengthy history of it, nobody had ever documented that these eye bolts that were used during the original construction were never taken out and now needed to be preserved as part of the historic fabric of it. So this is one of the additional challenges to working on Park Service and historic structures, that you have the best information available and you get out there and you start working and something still changes. So being an engineer means being able to adapt to change. We adapted, we changed the design on the footings. Obviously they got built, the scaffolding is up. This is kind of, if you know what to look for, up in the corner there by the red, you can see a little bit darker gray. That's where one of the haunch repairs will be. It kind of shows how we're supplementing the stone with a little bit of metal work in order to reinforce the areas where the stone is cracked. Now, there's a very conscious decision made during the design process that none of the repairs we are doing are intended to strengthen the monument and allow it to stand up to lateral loads any better than it already did. The current consensus is that that was the biggest earthquake we would have designed for anyway, it survived it. We need to address making sure that the places where the cracks did structurally weaken it, we bring it back up to its original strength and function, but not strengthen it beyond that, because it will find a different place to break. There are a number of interesting pieces in it. So some of these are pretty unique, and they require a little more unique kind of a fix. Here's one where the tie beams, which are the kind of sideways ones up in the center of the illustration there, some of those cracked, and trying to get those supported required a little more ingenuity. So the new metal straps and hangers to get those back together is the proposed fix in that area. Now, this is ongoing data work. The seismic study was complete. That's where our consultants have said they believe this to be the largest earthquake that this would have been designed for under current code anyway. Like I said, there's ongoing work still to understand the actual mechanics of East Coast earthquakes, as this is a very big one and was pretty unexpected. So Lehigh and VTech are still working on that. I'm not sure when their work will be done. The geotechnical borings and analysis were complete. The main thing there that concerned people was with high groundwater and a very sandy soil, during an earthquake, an event called liquefaction can happen. And the easiest way to think of that is temporary quicksand. Well, obviously, we were concerned that if the ground conditions were correct under this, that might happen. And if so, what could we do about it? Well, that study showed that this is not soil that's susceptible to liquefaction. The National Geodetic Survey did complete their survey. They published a nice little 4 or 5 page article on that on their website, and the basic answer they came with is that even measuring to a thousandth of a meter, they could not detect any change in vertical elevation of the Washington Monument from before the earthquake to after the earthquake. So it did not settle, it did not tilt. There is no evidence that the foundation was susceptible to earthquake damage, and no evidence at the surface that any earthquake damage happened whatsoever to the foundation. So that's all good stuff. We're very happy about that. The elevator has been repaired. The repair work is underway. They started about December 1st. About December 10th, we got a call from the inauguration committee saying, can you please not put any scaffolding up around the Washington Monument until after the inauguration. So we managed to get 10 days work in before the first delay. So this is working in Washington under the spotlight of everybody and wanting the Washington Monument to look good for inauguration. And now that we've got it all up together, you probably are aware we had a big ceremony Monday night and how we're going to make it look good even though it's all under construction. So there's a significant effort that's gone into both the looks and the approach of it so that during construction it doesn't necessarily look like a construction eyesore. But we are getting the repairs done. It will be finished in about February or March, maybe as late as April of next year. We'll take all the scaffolding down and reopen, and everybody can come look at it. We're even in the midst of a project that had been kind of on the boards for a while to update the interpretive media and kind of improve the museum level at the 490 level. So that'll have all new materials and all new interpretive materials in it when we reopen. So we're taking the opportunity to enhance the visitor experience from an educational point of view as well. Any questions? Oh, thank you very much for having me.